So we've talked about the law of sines. Now we're going to use the law of cosines. The law of sines helped us when we needed to find sides, and we had two angles in it and a excluded side, or if we had two sides and a included, or actually non-included angle, and so on. But now when we have just side, 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 or side, angle, side, we have a dilemma because it doesn't work. We were missing an angle in order to get our proportion set up properly, or we have the two sides in the included angle and we don't have a full proportion. So when we are looking at the law of cosines, first of all, you don't have to memorize all of these formulas, right? Because you should see a pattern here. Okay? If I know angle A, or I want to find side A, notice that they're on far ends of each other as far as the equation is concerned. So a squared is b squared plus c squared. Looks kind of like the Pythagorean theorem here, doesn't it? But then we take a minus 2 times the b and c, and then it's times the cosine of a. Or, yeah, you can just write it once and then just substitute in different variables, right? B squared, notice the cosine b is on the far side away from it. B squared is a squared plus c squared minus 2 of these a times c's times the cosine of b. And finally, c squared is a squared plus b squared minus 2ab times the cosine of c. Now, watch what happens if we want to rearrange it. Okay, if I want to get this cosine of a all by itself, I know all three sides, but I want to figure out what the angle is. Okay, then we're going to have to, first of all, bring this a squared to this side, so it's being subtracted. And then we're going to move the 2bc cosine a over here and then divide. So this is what it looks like. Like I got a little creative last year when I put this together. Yep, if you want to have the angle isolated and then figure out what the angle is. And again, you don't have to memorize all these different formulas. We just realize that if we're wanting to get the cosine of A or the cosine of B or the cosine of C by themselves, we just rearrange it by first taking the B squared, C squared to the other side and dividing by that negative 2bc. They are big equations, but you'll use them enough to where you'll have them down, and they're not hard to memorize once you get the hang of it. So I would memorize just one of these and then learn how to substitute different things in. The big thing to remember with these is to watch your order of operations. Okay, you'll do fine as long as you pay attention to what you can and cannot do. All right, so here's how it works. So we're wanting to find the three angles when we're given these three sides. So one side has a measure of 9, another of 14, and another of 12. And we want to find out what the three angles are. So notice how we have side, 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 three sides, no angles given. That tells us we need to use law of cosines. So let's label our points A, B, and C. And then we just need to decide which one we're wanting to solve for first. Okay, so we could be, oh, I'm sorry, I put them in the wrong spots. A was opposite 9. I didn't see the sides were denoted. Good catch. A is opposite the 9, so this is A. B is opposite 12, and C is opposite 14. All right. Now, knowing what I know about the next example, let's not find A first. Which one do you want to find, B or C? B? Okay. The only reason is I want you to see the formula more than one way. Okay? So let's find B first. Okay? We're trying to find angle B. That means that we start with a B squared, right? And that's going to be equal to, and over here we're going to have our cosine of B on the very far side. Okay? So what goes here? A squared plus C squared. Exactly, minus 2ac. And then the cosine of B. Yep. And we're going to have to move things around. Okay? So let's plug things in. We know B is 12. We know A is 9. We know C is 14. 2 times 9 times 14 times the cosine of angle B, which is what we're trying to find. So we write all of our stuff, substitute all of our variables in. Now, order of operations says we always do what? Parentheses, and that's more of a grouping, right? Okay, so we don't have anything really grouped. Those parentheses up there are mostly multiplication signs, right? We don't like to put the dots there. So what would be next that we would have to do? Exponents. So let's do all of our squaring next. Okay, so 12 squared is, 9 squared is, 14 squared is, yep. 2 times 9 is 18, 18 times 14. 18 times 14 is what? All right. Okay, thank you. All right, so that took care of our exponents. Now, what do we have to do if we're trying to solve this? Absolutely, combine your like terms. So we've got 144, 81 plus 96 is 277. And we're still trying to get that cosine of B all by itself. So what would be the next step? Yep, move the 277 to the other side. So we're subtracting it from both sides. We're going to get a negative, and that's okay, because we have a negative 252 cosine B over here. And negative 133, right? And now we do what? We divided everybody by a negative. Now we don't have negatives anymore, right? And then we have to divide by 252. So we know that the cosine of B, give myself some space here, is going to be equal to what's a negative 133 divided by a negative 252. 527-ish, right? And how do we get the, exactly, because we want to get rid of the cosine, so the inverse of cosine is inverse cosine. We take the inverse cosine of both sides, and angle B is 58.91, what was it? Let's do the two places. 19, unless they tell us otherwise. I think the book's been saying 2 decimals. Oh, still going to be 2? 58.2. Okay. Yep, so it would be 58.2. And I write a 5. Okay. So that's our angle B. Good news is we did all the heavy lifting. We don't have to use the law of cosines again. Okay? If you want lots of practice on it, you could do it again. But now that we have 58.2 here, what can we use? Law of sines, absolutely. Okay? So sine of 58.2 over 12. Now which one are we finding next, A or C? A. So sine of A over 9. Yep. And so the sine of A is going to be approximately what? Sine of 58.2 divided by 12 times 9.76, right? And then we want to find out what angle has that sine, so we do an inverse sine. get 31.69, so 31.7. 40. Did I type it in wrong? Oh, I didn't close my parentheses. See what happens? All right, my fault. So 0.63 instead. Thank you for catching that. And then A ends up being what? 39.6. And then 180 minus those two gets us our last angle. So 39.6 plus 58.2 from 180 is an 82.1. And a good check on these is your largest angle should be opposite your largest side, your smallest angle opposite your smallest side, right? So you know whether you're doing this right or not. 82.2, thank you. Yep. Okay. Good? Questions on this one? That's what we're doing. We're doing long cosines, but then we also have one more thing to talk about, okay? So let's look at it the other way now. This was if we had three sides, right? Let's see what happens when we have the side angle side case. So again, we don't have to memorize a whole nother formula, right? What's that? It's basically what we did, but this time we have the angle and we're looking for the other side, whereas the first time we had all three sides. So what formula are we using in this one? Which version of the law of cosines? Yep, the a squared is b squared plus c squared minus 2bc cosine a. So this will look a little different. So we don't know a, but 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of a, and a happens to be 75 degrees. Yep. Exactly. So now we just work our way through, but we have to do the order of operations, so we're going to do our powers first, right? So 144 plus 100 minus 2 times 12 times 10 is 240. Cosine 75 is equal to a squared. The parentheses are more of they're holding the place of a times sign, so we could think of those as being times instead of parentheses. So when we say the order of operations is parentheses first, so we're really meaning grouping symbols. And so something like 3 times 5 plus 7, we do that. Exactly, exactly. So we're not so concerned about the fact that we use these parentheses. They're not really, they're multiplication signs. So combine our like terms again, right? So 144 plus 100 is 244. And so we're taking that 244 minus, and don't take away the 240 and call it 4 times the cosine of 75. It's the 240 times the cosine of 75 that has to happen next. So your calculator, though, is hopefully, I think all of you have a smart enough scientific one, but also your graphing calculator is smart enough to know the order of operations here. So 244 minus 240 cosine 75 will get us a big number like 181.88. Yep. So square root. And we get 13.49. Equal to. Okay. And then from there, law of sines again, right? Find another angle and then 180 minus. Okay? Does anybody need to see more of that, or you're good? All right, last type of problem to talk about. So when we learn the law of sines, we also learn how to find the area of triangles, right? Well, we're also using the, oops, sorry, I forgot one more question. Here's how we would do a real life problem. Okay, A ball is hit 160 feet down the left baseline, and the left fielder throws to second base. How far does he throw the ball? You see it? We'd have to use a law of cosines here again. Okay, so let's just set it up. We're trying to find the distance from the left fielder, 160 feet out, to the second baseman at second base. Line drives straight down the third baseline. Okay, so what's it going to say? A squared or d squared in this case, right? We can throw a different variable in there. It shouldn't hurt a thing. It's going to be equal to 85 squared plus 160 squared minus, yep, times the cosine of, yep, because a baseball diamond is, for the most part, a square, isn't it? And the diagonal is going to bisect that angle. And then we work it from there. Nobody needs to see that worked, right? All right, so here comes our formula for finding area. So Heron's area formula says that if you know 3 sides of a triangle, then you can find the area of that triangle, provided you can add those 3 sides up and divide by 2, and then take that S and subtract everybody off, multiply them. So the area is the square root of S times the quantity S minus A times the quantity S minus B times the quantity S minus C, where S is A plus B plus C divided by 2. So it's not the average of those 3 sides. It's the sum of the 3 sides divided by 2. So let's see it in action. So now we have a triangle that has 3 side lengths, 11 feet, 16 feet, 24 feet. And we're asked to find the area. So the first step is to find what? S. So if we want S, yep, add the 3 up, divide by 2. So we get 51 divided by 2, 25.5, right? Now we need a square root, and then we take that 25.5, and we're going to multiply it by 25.5 minus 11, 25.5 minus 16, and 25.5 minus 24. That's going to be just a plain old 1.5. So 25.5 minus 11 is 14.5. 25.5 minus 16 is what, 19.5? 9.5. And 1.5. Bless you. Multiply them all together, take the square root, you've got the area. So we get the square root of 55,268.9735. If I've not hit some buttons wrong, 72.6 feet squared. What you got? All right, make sense? All right, just plugging and chugging in a formula. All right, assignment.